I want to do an example of the Lorentz transformation equations. In this particular example, what I'm going to do is apply the Lorentz transformation to derive the equation for length contraction. So I've drawn a picture on the board. I have an object that's going to be moving by us. This could be a rocket, it could be whatever, but or it could be a car, anything. But its length is L naught. This is the proper length of the object. This is the length of the object that's measured in its own frame. In other words, the observer is moving with the object. Okay, and I've written this up there as a reminder that proper length is measured in the rest frame of the object, meaning that you are moving at the same velocity as the object. So the proper length of this thing is L naught, and we want to look at what we would observe as the length. Okay. Now, if we're going to measure the length of this object, okay, we need to measure the positions of the front end of the object and the back end of the object at the same time. Of course, when this is done in the same frame as the moving object, we call it the proper length. Okay. So I'm going to use the velocity transformation, the Lorentz transformation equation. And since it's moving along the x direction, I'm going to write the following. I'm going to say delta x prime is equal to gamma times delta x minus v sub x times delta t. Why do I'm using deltas instead of just the x's? Because I'm calculating the difference in the positions of the locations of the front end and the back end of this object. So I'm looking at the change in position. So in this case, it would be the length. Okay, or I shouldn't say the change in position, but the difference in positions. Now, in order for me to measure length, I have to measure the location of the front end of the object and the back end of the object at the same time. So these are quantities that I measured. So these are the quantities that I measure. So I'm going to measure them at the same time, so delta t is 0. So that leaves me with delta x prime equals gamma delta x. But delta x prime is just this length, which we know is the proper length. And delta x is just the length that you measure, which we'll call L. And so if you solve for L, you get L naught over gamma, which is the equation for Lorentz contraction.